Hey, welcome to the deep dive. You're probably here because you need to get up to speed on something technical, pretty quickly.
Yeah, and today that something is OpenShift administration.
Exactly. We're going to try and give you a fast track, looking at some really key concepts, especially useful if you're, anywhere near modern apps or IT infrastructure.
We've actually pulled together some practice questions. They're from the RedHat Certified Specialist Exam for OpenShift Admin. That's EX280.
Right. But look, even if you're not planning on taking that specific exam, don't tune out these questions. They're gold mines.
They really are. Packed with practical stuff about managing containerized apps on OpenShift.
So our mission today isn't just about, getting the answers right for these questions.
No, not at all.
It's about digging deeper. What principles do these questions actually show us about OpenShift admin?
We'll break them down, look at the question, the answer, and then, crucially, why it's the answer and what that tells us more broadly.
Think of it as a shortcut to understanding some core ideas. Sound good?
Sounds great. Let's jump in.
Okay, first question up. Which command can be used to view detailed information about a specific pod in OpenShift? And the options are A, get pod details, B, describe pod, C, list pod, D, show pod status.
All right, and the correct answer there is B, describe pod.
B, describe pod. Got it.
Yeah, so the command is awk describe pod. And the reason it's so useful is the sheer amount of detail it gives you.
More than just the current state, right?
Oh yeah, way more. It gives you the history, like events that happen to the pod, the status of all the containers inside it, metadata. It's a really deep look.
A look under the hood.
Exactly. And that ability to see all that granular detail, it really speaks to, a basic principle of managing these systems. Good troubleshooting needs deep observability.
That makes a lot of sense. If a pod's acting weird, awk describe pod is probably your first stop.
Pretty much always.
You can see if it had trouble pulling the image or maybe issues with health checks, probes.
Right, or scaling events.
Yeah.
It lays it all out like a timeline with all the vitals in one spot.
So, key takeaway for everyone listening, need the full story on a pod. Oxy describe pod.
Absolutely. Understanding that pod lifecycle and state is just fundamental for day-to-day stuff, and especially when things go wrong, saves a ton of guesswork.
Okay, cool. Let's move to question 2.
Okay.
You need to limit the number of simultaneous connections to a service in your OpenShift cluster. Which resource should you configure? Options: A, network policy, B, resource quota, C, pod security policy, D, limit range.
And the answer for this one is A, network policy.
Network policy. Okay, now my first thought when I hear network policy is usually security, locking things down.
And you're not wrong. It definitely does that. Big part of securing the cluster, controlling traffic.
But it also controls the number of connections. That's interesting.
It does, indirectly.
Yeah.
See, network policies let you define really specific rules, like how traffic flows between pods or even from outside. So by setting up those rules carefully, you can essentially manage how many connections can be made to a service. It's like setting up, access control lanes, who can get in, and maybe limiting the volume that way.
Ah, right. It links back to that idea of least privilege too, doesn't it? And network segmentation.
Precisely. Better resilience, better security.
So it's not just allow deny, it's more conditional, like only allow connections from these pods in this namespace.
Exactly. Which inherently limits the potential sources of connections.
So quick follow-up then. Why wouldn't you use something like, say, a resource quota for this? Feels like it might fit.
That's a really good question. Resource quotas are all about consumption limits for a namespace. Think CPU, memory, storage, total number of pods maybe.
Ah, okay. Resource usage, not network traffic specifics.
Right. They don't manage network connections at that application level. And pod security policies. They're about what pods are allowed to do, their security settings. And limit ranges. They constrain resource requests or limits for containers. So, yeah. Important tools, all of them, but for limiting connections specifically, network policy is the one.
Clear. Okay, question 3. Deployment strategies. Which deployment strategy in OpenShift ensures zero downtime during a rolling update? Options: A, recreate, B, rolling, C, blue-green, D, canary.
And the answer you're looking for is B, rolling.
Rolling, okay. Zero downtime deployments. I mean, that's table stakes now, isn't it? Nobody wants their app to just disappear during an update.
Absolutely critical.
So how does the rolling strategy actually pull that off, make it seamless?
Well, think about keeping the lights on. The rolling strategy works by gradually phasing out the old pods and phasing in the new ones.
Bit by bit.
Yeah. OpenShift spins up a few new pods with the updated code, waits for them to be ready, actually checks they can handle traffic.
And then gets rid of some old ones.
Exactly. Then it terminates a few old ones. It repeats this incrementally. So there's always a healthy set of pods, either old or new, or a mixed serving requests.
It's like changing a tire on a moving car, almost.
Yeah, something like that. It highlights the trade-offs, risk, resources, user impact. Rolling balances those quite well for this specific goal.
Because the other options, recreate, just stops everything old, then starts everything new. Definite downtime there.
Yep, unavoidable downtime.
Blue-green needs basically double the infrastructure, right? Two identical environments you switch between.
Can be resource intensive, yeah, though very safe if done right.
And Canary is more about testing the waters with a few users first.
Right, a gradual exposure strategy, not strictly zero downtime during the main rollout phase itself for everyone.
So for that core requirement, uninterrupted service during the update process itself, rolling is the built-in answer.
Exactly. It's designed for that end-user experience, making updates feel invisible.
Okay, number 4, traffic routing. Which OpenShift features should you use to manage traffic routing between services within the cluster? Choices are A, Ingress, B, Route, C, Service Account, D, Network Policy.
The correct answer here is B, Route.
Route. Okay, this one trips people up sometimes, I think, especially with Ingress being common in the wider Kubernetes world.
Yeah, there's definitely overlap and potential for confusion.
So let's clarify. In OpenShift specifically, what's the job of a route?
Okay, so think layers. While both routes in OpenShift and Ingress in Kubernetes deal with getting external traffic in, route is OpenShift's native, primary way to do it.
Exposing services running inside to the outside world.
Precisely. To external clients. A route defines how incoming HTTP or HTTPS traffic gets directed to the right service and then to its back-end pods. It's that specific bridge.
Okay, bridge to the outside. But the question asked about routing between services within the cluster. Does a route handle that internal east-west traffic too?
Ah, good catch. No, not directly. For that internal service-to-service communication,
Good use.
you'd typically rely on the standard Kubernetes service abstraction itself, often using the default cluster IP service type, which we'll probably get to. And network policies, like we just discussed, control if that internal traffic is allowed to flow between specific services.
So route, external access manager. Service cluster IP, internal address. Network policy, internal traffic hop.
That's a pretty good summary. Route is the front door to the outside. Ingress does a similar job in vanilla K8s, but OpenShift uses route natively.
Got it. That distinction helps. Okay, question 5. Which resource in OpenShift ensures a pod runs on a specific node based on node labels? Options. A, deployment, B, stateful set, C, pod disruption budget, D, affinity rules.
And the answer is D, affinity rules.
Affinity rules. Okay, so node labels first. Those are just key value pairs you stick on your worker nodes. Yeah, like metadata.
Exactly, like tagging them region east 1 or disk hypes D or has coup true, just ways to describe the node's characteristics.
Simple enough. So how do affinity rules use those labels?
They let you tell the scheduler where you want your pods to run based on those labels. It's about expressing preferences or sometimes hard requirements.
Okay, so you can say, I'd prefer this pod on an SSD node.
Right. That's preferred affinity. The scheduler will try to honor it, but if it can't, the pod still gets scheduled somewhere else.
And the alternative?
Is required affinity. This pod must run on a node with a GPU. If no such node is available and meets other criteria, the pod just won't get scheduled.
Ah, okay. That gives you a lot of control. Useful for what? Performance, data locality.
All of the above.
Yeah.
Performance, maybe sticking compute close to specific data, regulatory needs like keeping pods in a certain geographic zone. It's about optimizing where workloads run.
Right. And the other options here, deployments, stateful sets, they manage pods, but not where they land based on node features.
Correct. They manage the what and how many, not the where, based on node labels.
And pod disruption budgets are about availability during maintenance. Totally different thing.
Yep. So affinity and its counterpart, anti-affinity, for keeping pods away from certain nodes, is the tool for node-based scheduling preferences or requirements.
Makes sense. Fine-grained placement control.
Precisely. Powerful stuff for tuning your cluster.
Okay, question 6 should be straightforward. Which command should you use to delete a specific deployment in OpenShift? Your options. A, delete deployment. B, remove deployment. C, delete pod. D, delete application.
This one is pretty direct. The answer is A, delete deployment.
Feels almost too easy, but syntax matters, right? Especially with destructive actions.
Absolutely. Getting the command right is key.
So what's the actual command line look like?
It's awk delete deployment and then the name of the deployment. So awk delete deployment, my app deployment, for example.
And when you do that, it's not just deleting the deployment object itself, is it?
No, that's important. Deleting the deployment typically triggers a cleanup. It'll also delete the replica sets that the deployment manages.
And the pods themselves.
And the pods managed by those replica sets. It's usually a cascade.
Right. So option C, delete pod, would just zap one pod, and the deployment would probably just spin up another one to match the desired count.
Exactly. You'd be fighting the controller. So awk delete deployment is the clean way to pare down that whole application component.
Fundamental lifecycle stuff. Good. Moving on. Question 7. Which service type should you configure to allow users to access services exposed only within the cluster? Options. A, node port, B, cluster IP, C, load balancer, D, route.
And the correct choice is B, cluster IP.
Cluster IP. We sort of touched on this when we talked about routes and internal traffic.
We did.
So this is the default internal-only service type, right? How does it actually work?
Well, when you create a service of type cluster IP, which is the default if you don't specify a type, by the way, Kubernetes gives it a stable virtual IP address.
Virtual meaning,
Right.
not tied to a specific pod.
Yeah, right. It's an IP address that lives only inside the cluster's internal network. Other pods and services in that cluster can reach the service using that IP.
But nothing outside the cluster can hit that IP directly.
No external exposure by default. It relies on the internal network routing Kubernetes sets up.
Okay, so perfect for like a back-end database or some internal API that only your other microservices need to talk to.
Exactly that kind of scenario.
Because the other options, A and C, node port and load balancer, are explicitly about external access.
Right. Node port opens a port on the node itself. Load balancer usually provisions a cloud provider load balancer.
And root, as we established, is the OpenShift way to expose HTTPS externally.
Yep. So cluster IP is your tool for keeping things internal, enforcing that boundary. Important for security and architecture design.
Makes sense. Okay, last question for this dive. Number 8. Which command would you use to view the logs of a container in a specific pod? Choices. A, view logs. B, get logs. C, describe pod. D, show pod status.
The answer here is A, view logs, though the actual command is awk logs.
Awk logs. Right, essential command. I mean, if something's broken or even just to see what an app is doing, logs are everything.
Couldn't agree more. Debugging without logs is painful.
So awk logs lets you peek inside a running container's output.
Basically, yes. It streams what the container process writes to standard output and standard error.
So whatever the application prints out.
Exactly. And you've got options too. You can follow the logs live using F, like pale.
Oh, useful.
Yeah, or see logs from a container that crashed and restarted using previous. Or if you have multiple containers in one pod, you can specify which container's logs you want to see.
Okay, so awk describe pod gives us the pod's overall health events configuration,
The metadata and state summary.
whereas awk logs gives us the application's actual output, the voice from inside the box.
Precisely. It's your window into the runtime behavior. Indispensable, really. The other options listed just don't do that.
Got it.
Yeah.
Foss logs for the actual application chatter.
That's one.
Phew. Okay, well, that wraps up our run through these questions. Hopefully this deep dive gave you a solid footing, maybe sparked some interest to explore certain areas more. There's always more to learn in this cloud-native world.
For sure. Consider this a springboard. Thanks for diving in with us.